Our next speaker is Laura Aivar from GMV, and she will talk about the laser ranging evolution toward active sensor networking for debris observation.
Okay. Good morning, everyone. Thank you for being here today. I'm Laura Aivar, as Emiliano just presented me. I work at GMV, and I'm going to present the activity where I'm working now on that team has already introduced a little bit, and also Andrea, because we are colleagues in this activity. The activity is called Evolution Towards Active Sensors Networking for Debris Observation. This activity is funded by ESA, and we are working in a consortium of enterprises that is DIGOS, IWF, LibreSpace Foundation, and also us, who are the prime contractor. My idea today here is to present this whole activity to you in order you to be aware of what we are doing, and if you are interested, maybe collaborating with us in the future. I'm not just the one struggling with that.
You just try the thumb button?
The thumb button?
Yeah.
No? Okay, thank you, Emiliano. Here we have the agenda. After this brief introduction, I will talk a little bit about the background, what led us to start this activity. We're going to continue with the objectives of this activity. And then I will talk a little bit about the planning, because we are still doing this activity. We are not working on it. And I will present you the current status, where we are now, and we will come next in the next steps. So the background, as you all know, because you are the world experts of laser ranging stations, laser ranging has been a well-established technology in the scientific field for having a very precise ranging for the satellites, and that gathers very important information for the orbit determination afterwards. And then thanks to the evolvement of the technology in these recent years, there are more powerful transmissions, the more sensitive receivers, and also the tracking initialization is more accurate, and that opened the door to track to non-collaborative objects, which are the space debris, which are the main focus here. And opening that door, we saw that there is a market there, a niche for the SST, the space surveillance tracking. And because we can use these measurements as complement, because they offer very precise information for our cataloging, and also for supporting collision avoidance and re-entry predictions. We don't need to go very back in time. Last week we have a very quite dangerous re-entry event, the Chinese body. Here in Spain, for instance, we were quite worried because the 2 or 3 final predicted orbits were flying over our territory, and even some areas of the air traffic were closed, which was one of the first events in the history. So that's a problem that we are facing now, and that's going to come more in the future, so we need to be prepared of that. And finally, okay. It's okay, don't worry. We want also to support the future for laser momentum transfer operations. So, taking all these ideas into mind, ESA proposed this activity where the main objective is to establish a proof of concept of fully automatized SLR stations. This will include the upgrade of Isanya 1 station for tracking non-cooperative targets, and also to develop the real laser tracking network. From now on, I will call it the LTN, that will connect users and contributing stations, and that could be operated commercially. That's a future idea for this network. And also, it's important that we are going to be running a test campaign during this activity to test that everything that we've put it into place, it's working. Among those objectives, we can split it in 2 main groups. The first one is related to the debris laser ranging network, the DLTN. We are going to develop, deploy, and test an online sensor network platform. And the idea for this network platform is that it will be able to real-time request, schedule, analyze, display, and providing SST-related products to the final user. It's very important to keep in mind that this network approach, because the fact of working in a network approach, gathering information from different stations across the globe, gives us a very important information, and it's better to use that network approach instead of isolated stations working on their own. We want to use already existing and also evolving assets in Europe, but as we're here things are changing very fast, and that's good. And we want to include all of your work into our network. And one of the most important requirements of this network is also that it should be as automated as possible. We don't need to rely on operators to use it manually. It should be as automated as possible. And we are also going to reuse experience of other networks that are already existent, not for SLR stations, but for other kind of stations like radio frequency. This is a SAT-NOX network that is developed and maintained by our Libre Space Foundation, which is also part of our consortium. The second group of the objectives of this activity is the upgrade of Izaña 1 station, as André has already presented in the previous presentation. So here we have the timeline and the milestones that we are going to have in our project. This is quite a recent project. We started that that summer, so some months ago. And now we are already facing our first milestone, and very important. That's going to be the design review for both parties, the Izaña 1 station and also the DLTN system. And it's going to be at the end of this year, so we're quite soon there. That's going to be the trigger for starting the design and implementation of both parties too. And the reviews of these parties will be end of summer to the next year, 2023. And then it will take place a validation campaign that it will take place during the first semester of 2024, and it will rise to the conclusions of our project, and it will end at fall 2024. So as you see, we are just doing the first steps of this activity. Now I'm going to focus on the current state too. As André has already explained the part of Izaña 1, I'm going to focus on the part of the DLTN. The first thing that we need to do is to define our system. What is our system? Our system has been considered to be mainly formed by two parts, which are the stations on one part and the online platform that's going to be orchestrating the stations. The online platform is going to be requesting the observations, and then it's going to gather the data and produce all the final products that's going to be the importance for the final user. The general capabilities of the system. What does this system offer to the user? What can the user ask to it? We have defined very different use cases, going from the simple one to the most complicated one. The user can just ask for some observations. I want these observations. We calculate them and they provide back. They can also ask for refinements of orbit information, of collisions data messages, and also for re-entry data messages. They can also ask for the maintenance of a catalog of the LEO, GEO, and MEO satellites, because SLR measurements give very precise information that will keep this catalog going on. And they can also request chase operations after a stair observation. And finally, we need to assure that these stations are calibrated to offer good results to our clients. Okay, what kind of actors do we have in this system? The first and the easiest one to identify is the observation requester, like the final user is going to be the one that's going to request for the final products. The final products, they are not just the observations, but the orbit, the refined CDMs, the refined RDMs, etc. And they can be just satellite operators or satellite owners or just people that are interested into this field. Can also be ESA or other organization. Then we have the platform administrations that are going to be the responsibles for the administration of the platform, and not only adding stations and managing users, but also assuring the quality of this data. It means doing the station's calibration. Now we go into a deeper level. Now we're going to talk about the online platform. The online platform needs to offer very different functionalities. We have here the main functional components that we have identified. We can see some that they are like more in an informatical base, like handling the inputs and the outputs that we are gathering, storing it into the database, automating that, and so on. And then in the highlighted square, we have the ones that are more related to flight dynamics. It means all the orbit propagations needed, the observations opportunities calculation to request and schedule the stations, and then gathering this information and doing the orbit determination, the collision calculation, the re-entry calculation, and so on. All these functionalities are going to be provided by already existing codes of GMV. Here we have a diagram of the architecture that we have defined for our online platform. So we have an application web server where the user can connect, and it's going to be directly linked to the front end. The front end is going to be providing all the graphic interface to the user to make it like easier and prettier and to understand all this data that we gather. And then the front end, it's going to be directly linked to the back end. The back end, we need to think about it as the real orchestrator. He's the one that's going to be gathering all the data and transmitting it to where it's required, maybe the database to store it and then retrieve it when it's needed, or also launching the computational models, the codes of GMV that I have already told you, to doing the calculation required for after offering the product. And they are, the backend also is going to be connected to an SFTP server, because we thought that stations, they like to work as simple as possible. So we don't want to impose to them to install a software, so on. We thought the communications with the stations, it means the sending of our requests and then gathering their observations, can be done using an SFTP server. It's very simple. The only thing that we need to do is to assure to use a standard format, like the ones coming in the CCDS, or they're very known for you, the CRDs and CPF. Okay, last but not least, we are also starting to develop and planning our observation campaign, even though it's going to be in the first semester of 2024, so still 1 year to come. We are starting to see which stations want to be part of it. Okay, so we have already asked some of you if you want to be part of it. We have already acceptance of some of them, like Simmerval, Graz, Borovec, coming in China, and Montestromlo in Australia. For sure, we are going to count with our star, with the Isanya 1 station for that. And if I have contacted you or some of our group, and you have not answered yet, but you are interested, please answer or come to me anytime. And if I have not contacted you, but you are also interested, also please come to us, and we can discuss about it. So the next steps to come, as I told you, now we have very soon the design review of both parties at the end of the year. So it's our milestone, and that's going to be the trigger for starting the validation in our, the implementation. In our part, it's going to be the DLTN online platform development. It's going to be an agile software development of 8 to 9 months. Then another important thing that we're going to start working on is the elaboration of the business case for a commercialization of this service, because the idea of this service is that once the activity will be finished in 2024, to be offered as a commercial service to everyone that wants to use it. So we're going to start working in a business case to define all the actors and the conditions and the market of it. And regarding the validation campaign, we're going to start working in the service level agreements with the companies that have already accepted being part of it, and also planning this validation campaign. That means maybe take into account some of new members that you want to join, and so on. So if you want to be part of it, just tell us. You can talk to me or to Tim or to anyone, and you will be very welcome. Thank you very much.
Thanks, Laura. We have time for a very quick question. If not, I will thank our speaker. Since we are running out of time, I would suggest to contact Laura in the coffee break.